Good morning, students. Now we see about the electromagnetic induction. So what is electromagnetic induction? In this chapter we have studied that when a current carrying conductor is placed in a magnetic field, it experiences a force. This force results in the motion of the conductor. Now imagine a situation where if a current carrying conductor is moved through a magnetic field, an electric current is produced in the conductor. This phenomenon was first studied by the Michael Faraday. Let us perform an activity to observe this. Okay. So here, what is electromagnetic induction means? So when a current carrying conductor is placed in a magnetic field, it experiences a force. Thus force results in the motion of the conductor. So for example, here you see this is the electromagnet. So it has some field, okay, some force, some magnetic force of lines are there. So in this magnetic field, when we place a current carrying conductor, so this is the conductor, one metal, copper metal which conducts the electricity. So current carrying conductor we place in between them. So when we place current carrying conductor in between the magnetic field, so it will experience some force, some strength it will experience, and when the wind is coming, so leaves are there. Because of the wind, leaves will be flying. So leaves has the motion now. Motion means what? Moving. Now it started to fly. So leaves experience the force from the wind. So like that only, this current carrying conductor will experience the force from the magnetic field. So because of this magnetic field, this current carrying conductor will experience some force, some strength, and it will started to move. It is called as a electromagnetic induction. Okay, this is the electromagnetic induction. If a current carrying conductor is moved through a magnetic field, an electric current is produced. Okay, so when the one conductor, copper conductor or any metals which conduct the electricity, when we keep them in the magnetic field, they produce the electricity. It is called as a electromagnetic induction. For example, here we are taking, this is the copper wire. Okay, this is the copper wire. But here you see there is no any battery. Battery means which can supply some electricity. Na? This is only what? This is only the copper wire. Okay, current carrying conductor. One conductor. So in this, when we keep this bar magnet, it is the magnet. Na? So when this magnet is put inside this coil, so here electricity started to flow. So it is called as a electromagnetic induction. For example, you see, take a coil PQ having a numerous turns. Numerous means many turns like this. Na? So many turns of a copper wire. Join the two ends of the coil to a galvanometer. So this is the galvanometer. Add two joints here. So this is P, this is Q. And take a strong bar magnet and move its north pole towards the coil Q. Do you notice that deflection in the galvanometer of needle? For example, now you see this bar magnet is outside. Na? It is not inside of this. Now for example, you see no connection is given to this. But now if this needle is straight away, current is not flowing. If this needle started to deflect means what? When this needle started to change its direction means current is flowing. Okay. Now here this is the current carrying conductor and it has some magnetic field. So this bar magnet is started to move inside the coil. Now you see this galvanometer is started to deflect. That means current will be started to flow. So here also magnet is completely within the coil. When the magnet is completely within the coil, now galvanometer is as it is. So no deflection is shown. So current is not flowing. Magnet moves outside the coil. First we put inside the coil and removing now outside the coil. Left deflection. Now deflection is this side. Okay. So when the magnet is moving this side, it is showing this side. When magnet is removing from outside, so it is deflecting this side. That means this side is electricity started to flow. When it is moves this side, it will show electricity is flowing this side. Okay, so this is the one. So electromagnetic induction means when the electric carrying conductor, current carrying conductor, this copper conductor, metal is put inside the magnetic field. So this magnet has some magnetic field. So inside that magnetic field, it will experience some force and it will started to move. So current electricity will started to flow. It is called as electromagnetic conduction. Okay. So here you see Fleming's left hand rule. Okay, Fleming's left hand rule. For example, this followed the Fleming's left hand rule. Left hand rule means what? Now you see thumb. Force is this side when we keep, and this side is the forefinger, and this is the I am showing the left hand rule. This is the current flow. Okay, so this side is the thumb, it is showing this side. That means force is coming from this side, from the magnet, from the pole of the north side, and in the forefinger showing the magnetic field. So here magnetic field is like this, and this finger will show the flow of current. So current is flowing in this. So the left hand rule will be working in the motor. Okay, where electrical energy will be changing into mechanical energy in the DC motors. DC motors means direct current. Power supply will be from the direct current, not the batteries or anything. Okay. So this is the left hand rule. Now it is following this one, Fleming left hand rule, motor. But here this is the right hand rule. Right hand rule, you see this one according to the Fleming. It is very important. Fleming right hand rule, Fleming left hand rule. Okay. So according to this rule, spread the thumb, the first finger. Okay. And the first finger and the middle finger of the right hand. This will show direction of the motion. Motion means moving, and it will show the magnetic field, and this will show in the induced current. Okay, induced current means because of the magnetic field, force of the magnetic field, metal will be carrying the current. So it will show the induced current. Okay. Now this Fleming right hand rule we can see in the AC motors. It will generate the electromagnetic induction. Okay, here you see no batteries or anything. So magnet, because of this force, this conductor is put inside this magnetic field. Okay, because of this force it started to move, it started to rotate and converts the mechanical energy into electrical energy. AC motors alternating current generators will change the mechanical energy to the electrical energy. Motors will change electrical energy to the mechanical energy.